Hey, thanks for stopping in. Well, in the background, you'll hear a little bit of rain going down the downspout and a little bit of single sideband on 40 meters at 7190 or so, some kind of a net going on. So this is NorCal 40A experiment number 3. We'll call it maybe the spoiler alert. Causing it to fail would probably be the key piece. So I thought I was getting close to 4.8 watts out of this thing, but the driver was getting hot. So I thought I'll take out the plastic 2N2219A and put in a metal 2N2219A. Well, let's make this one quick, I guess. So if you look right up here, you can see that R12 and R11 are just under the can. They were standing up. Well, I pushed the can right down on top of the two resistors standing up. That causes the collector of that transistor, which is the can, to short to those two things, and that caused the transistor to go bad. And let's call experiment number 3 a fail. So I'll show you something interesting if you've never done this. You can take your multimeter. We'll put that over here where you can see it, but you only have to listen. So it's in test mode with, so there's the beep if we short them. So a good transistor, if I put the minus lead on the base, so we're conducting to the emitter, but not the collector. If I switch it around, you'll notice that it's still conducting on the emitter base junction, which is a short, and then from the collector to the base, that junction appears to be still good. So there's no conduction one way, and there is the other. So that's the failed one with a shorted emitter-based junction. I have replaced, I had 3 of these, I put 1 in it. So here's the remaining good ones. So we start on the base again. We go to the emitter and the collector, nothing. If I go from the negative lead on the, on the emitter to the base, that's good. And if I go from the collector lead to the base, that's also good. And if you remember, from the base to both of the others, there's nothing. So that's a good transistor. The other thing you can do is you can line up, emitter is the tab, base is the middle. If I can get these in here for you. So there's an emitter, base, and collector. And I can go to the HFE setting, which is the next one over. And it reads, whoops, that would be backwards. So emitter, base, and collector would be better. So that reads an HFE of about 174. That's a good transistor. And now we'll take the dead one. So here is, let's get those in shape here. So there's emitter, base, and collector again. So the notch is under my index finger, emitter, base, and collector. You can see it has an HFE of 0 because it has a shorted junction. So there's 2 ways to test a transistor. Bad idea to put a 2219 in when the resistors stand up. And then in addition to that, I had a great comment after I finished blowing up the transistor from a very helpful guy. And he pointed out right here in the manual where it says adjust R13 the drive. Here is R13, the drive control on the buffer. Adjust it so the max should be 1.8 to 3 watts, not to 4.8. Best setting is about 90%, which keeps the driver stage operating efficiently. In my case, when I got to the top, I did have oscillations, and I think that's what was causing it to get hot. And I wish I had the comment, but you can read on my other video, I think experiment number 2, he makes a very good comment about running the NorCal 40s at about 2 watts is a good thing to do. And I'm going to do that. I'm going to go back to the 2N2222, the plastic one, and I guess I'll do experiment number 4 with that to put it back to a 2N2222, and then we'll adjust it where the driver is actually putting out a nice sine wave, and hopefully we'll get to a 1.8 or 2 watts out. So thanks for watching. See ya.